So, Figure AI just shocked the entire robotics industry with the introduction of Helix, their newest AI that thinks like a human. For the first time ever, humanoid robots can now work together in real time to complete tasks. Meanwhile, Microsoft unveils Majorana 1, the world's first quantum chip powered by a new breakthrough topological core architecture. And lastly, Google DeepMind's new AI co-scientist cracks a super complex problem that took microbiologists over a decade to solve in just 2 days. Let's get into it. So, Brett Adcock, the CEO of Figure, made a massive announcement on X a few weeks ago, stating that he had made the decision to end his collaboration agreement with OpenAI, meaning Figure could no longer use OpenAI's AI models to power its humanoid robots. This decision was made due to a supposed major breakthrough Figure had made internally on fully end-to-end robot AI, and they would announce this breakthrough in the next 30 days. And well, here it is, introducing Helix, our newest AI that thinks like a human. He states, to bring robots into homes, we need a step change in capabilities. Helix can generalize to any household item. Now, I'll play you guys this demo here of Helix in action while I tell you a little bit more about it. So, Helix is a Vision Language Action Model, or VLA model, but it's not exactly your typical VLA model. As you'll see in this demo, the human places random household objects in front of the Figure robots and asks them to work together to put them away. The key thing to note here is that these random household objects are objects the Figure robots have never seen before. So not only is Helix the first VLA model to operate simultaneously on 2 robots, enabling them to solve a shared long horizon manipulation task with items they have never seen before, but it is also the first VLA model to output high rate continuous control of the entire humanoid upper body, including wrists, torso, head, and individual fingers. Figure robots equipped with Helix can now pick up virtually any small household object, including thousands of items they have never encountered before, simply by following natural language prompts. And unlike prior approaches, Helix uses a single set of neural network weights to learn all behaviors without any task-specific fine-tuning. So this is kind of insane. They're using purely vision models now instead of large language models to power their humanoid robots, which is allowing them to generalize better. They no longer have to spend hours or even days fine-tuning the model to perform a specific task. Instead, they just kind of throw the robot out there, have it perform a ton of tasks in the real world, and it kind of just learns on its own. This is essentially a new scaling law as they show here. The more tasks you give the robot, the better it gets without training. This reminds me of when Tesla abandoned LiDAR in favor of a camera-only approach for self-driving because vision-based AI models could generalize better with more real-world data. This Helix system is doing something similar, using pure vision models to allow humanoid robots to learn dynamically instead of relying on rigid pre-training. But what's even crazier about this is if these robots can learn on their own and work in fleets, you could theoretically have thousands of robots sharing knowledge in real time. One robot figures out how to pick up an odd-shaped toy, and suddenly, every robot in the network knows how to do it. This is basically an AI-powered hive mind, or collective intelligence, again, similar to Tesla's FSD. So, by all means, this is truly a major breakthrough. I've said this before, but I think humanoid robots will have their own ChatGPT moment, likely sometime this year, and people will start to realize how massive this industry will actually be. Now, there was some other robotics news before we move on. By the way, I apologize in advance, this will likely be a very long video. There was just a ton of fascinating AI news this week, from Figure's major breakthrough, to Microsoft's leap in quantum computing, to Google introducing a literal AI scientist. So, I mean, yeah, it's been a wild week, and I'll try my best to cover everything in this video. Now, this robot you are seeing on screen right now is 1X's Neo Gamma. This is 1X Technology's next generation of home humanoids. They don't really give us any information about the updates they made, but they claim the Gamma series includes improvements across Neo's hardware and AI, featuring a new design that is deeply considerate of life at home. So this is really just another example of how close we are to having capable humanoid robots in our homes. Another company, Clone Robotics, is taking a bit of a different approach. Meet Protoclone, a faceless, anatomically accurate synthetic human with over 200 degrees of freedom, over 1,000 myofibers, and over 200 sensors. So first of all, this thing is insanely creepy, but I get why building a humanoid robot like this could be useful. With so many degrees of freedom, it has a much wider range of motion, making it capable of performing more complex tasks. The only issue is there's no way I'm letting this thing into my house, at least not until it looks way less like something out of a sci-fi horror movie. Jokes aside though, the level of realism here is impressive, and if they can refine it and avoid a Westworld type scenario, this kind of technology could push humanoid robotics to a whole new level. Now, in other AI news, we had OpenAI introduce a new benchmark called the SWE-Lancer. The SWE-Lancer, or SWE-Lancer, is a new, more realistic benchmark to evaluate the coding performance of AI models. It includes over 1,400 freelance software engineering tasks from Upwork, valued at $1 million in total in real-world payouts. As it states here, SWE-Lancer tasks span the full engineering stack, from UI/UX to systems design, and include a range of task types from $50 bug fixes to $32,000 feature implementations. SWE-Lancer includes both independent engineering tasks and management tasks, where models choose between technical implementation proposals. So the prices of these tasks reflect real-world market value dynamically based on Upwork. And in total, the 1,400 tasks add up to about $1 million, meaning if a freelance human software engineer completed all 1,400 of these tasks in real life, he can expect to be paid about $1 million for his work. So before we move on to the next slide to see how well today's top AI models perform on this benchmark, I want you guys to take a guess. Out of the 1,400 tasks worth $1 million, how many do you think OpenAI's O1 model was actually able to complete? And if it were a freelancer, how much would it have earned? Take a moment to think about it because the results might surprise you. And once you have your guess, drop it in the comments and we'll see how close people get. Now, here are the results. They tested GPT-4o, O1, and Anthropic's Claude 3.5 Sonnet. The O1 model managed to earn about $380,000, while Claude 3.5 Sonnet, the best performing model on this benchmark, was able to earn $403,000, meaning it probably was able to solve around 40% of tasks. What's crazy is that these publicly accessible models can already earn a significant amount of money as a freelance software engineer. Now, imagine what happens when OpenAI or Anthropic build AI agents specifically designed to complete tasks like these. A fully optimized AI software engineer with tool access is probably a lot closer than people think. In fact, I wouldn't be surprised if we see one as early as this year. Speaking of OpenAI and their future potential releases, their COO, Brad Lightcap, recently took to X to announce the following. ChatGPT recently crossed 400 million weekly active users. We feel very fortunate to serve 5% of the world every week. 2 million plus business users now use ChatGPT at work, and reasoning model API use is up 5x since O3 mini launch. We'll bring GPT 4.5 and GPT-5 to chat and the API soon, with unlimited GPT-5 for free users, Plus and Pro users can run at even higher intelligence. GPT-5 will unify our GPT and O series models into a single powerful model. We think even low taste testers will love it. More agent capabilities coming this year as well, and a few other things. So these are some pretty wild numbers. ChatGPT is clearly still growing immensely, and more businesses are starting to integrate it into their workflow. They will be releasing GPT 4.5 soon, as well as GPT-5, which we already know will be a unified model of both OpenAI's GPT series and O series models. Also, more agents coming this year. Again, I wouldn't be surprised if one of these agents is a software engineering agent. By the way, I don't know if this tells you anything, but Sam Altman has stated that GPT 4.5 has been much more of a feel the AGI moment among early testers than he expected. Not sure exactly what he means by this, although I definitely can't wait to get my hands on it. Now, before we get into Microsoft's insane quantum computing breakthrough, there were two AI startups that I wanted to briefly talk about. The first one being ex-OpenAI CTO Mira Murati's new startup called Thinking Machines. This company has been in the works for a while now, and we finally got an official statement. Today, we are excited to announce Thinking Machines Lab, an artificial intelligence research and product company. We are scientists, engineers, and builders behind some of the most widely used AI products and libraries, including ChatGPT, Character AI, PyTorch, and Mistral. Our mission is to make artificial intelligence work for you by building a future where everyone has access to the knowledge and tools to make AI serve their unique needs. We are committed to open science through publications and code releases, while focusing on human-AI collaboration that serves diverse domains. Our approach embraces co-design of research and products to enable learning from real-world deployment and rapid iteration. This work requires three core foundations: state-of-the-art model intelligence, high-quality infrastructure, and advanced multimodal capabilities. We are committed to building models at the frontier of capabilities to deliver on this promise. So it looks like we have a new big player in the AI AI space now. Mira has managed to put together a pretty impressive team here, and they're focused on building models at the frontier of AI capabilities, while also prioritizing open science and human AI collaboration. Sounds very promising. I'll definitely be keeping you guys updated on this. The other AI startup I wanted to briefly talk about was Ilya Sutskever's SSI. This startup, founded just last year with the sole focus of creating a safe superintelligence, is now valued at around $30 billion after its latest funding round. I remember literally just a few weeks ago talking about how SSI secured more funding, putting it at a valuation of $20 billion, and now it's at $30 billion. We still have no idea what is actually going on behind closed doors at this company, yet they continue to raise billions of dollars like it's nothing. So definitely another startup I'll be keeping you guys updated on. Finally, we have to talk about Microsoft's new quantum breakthrough, Majorana 1. Majorana 1 is the world's first quantum chip powered by a new topological core architecture that Microsoft expects will realize quantum computers capable of solving meaningful, industrial-scale problems in years, not decades. It leverages the world's first topoconductor, a breakthrough type of material which can observe and control Majorana particles to produce more reliable and scalable qubits, which are the building blocks for quantum computers. So if you have no idea what I just said, don't worry, we will get into some more details here and it will hopefully all start to make sense. So basically, roughly 20 years ago, Microsoft set out to engineer a way to create and control Majorana particles. Majorana particles, which were only theorized to exist until now, are strange quantum particles that are their own opposites. Unlike normal particles that have a separate antiparticle version, Majoranas cancel themselves out without disappearing. This makes them special because it can store information in a way that resists errors and could lead to more stable, powerful quantum computers. Imagine a seesaw with only one person sitting on it, but somehow it stays perfectly balanced. Normally, for a seesaw to work, you need a person on each side, like how most particles have an antiparticle to balance them out. But Majorana particles are like a seesaw that magically holds itself steady with just one person. No need for an opposite to keep it in place. This unique property is why scientists think Majorana particles can help quantum computers run more reliably without the usual instability that messes them up. Now, to do this, Microsoft needed to develop an entirely new material stack made of indium arsenide and aluminum, much of which they designed and fabricated atom by atom. This special material is what they call the topoconductor, a custom-made structure designed to create the perfect environment for Majorana particles to exist and be controlled. As they state here, in the same way that the invention of semiconductors made today's smartphones, computers, and electronics possible, topoconductors, and the new type of chip they enable, offer a path to developing quantum systems that can scale to 1 million qubits and are capable of tackling the most complex industrial and societal problems. So just quickly, if you aren't aware of what a qubit is, it's essentially like a classical computer bit used to store information. However, unlike a regular bit, which can only be either 0 or 1, a qubit can exist in both states at the same time due to quantum superposition. So it can be both 1 and 0 at the same time, or neither. This allows quantum computers to process information in a massively parallel way, making them potentially far more powerful than traditional computers for certain tasks. So just like how a traditional computer with more classical bits will be able to store more information and process more data, a quantum computer with more qubits could theoretically process and store more data as long as they remain stable. In fact, each qubit you add, since it exists in superposition, both 0 and 1 at the same time, increases the amount of information the computer can store and compute exponentially. This is what makes quantum computers so powerful. While classical computers scale linearly, quantum computers scale exponentially with each qubit added. And as we'll read here, Microsoft believes they can scale this up to 1 million qubits, which would be a massive leap toward practical, large-scale quantum computing. This new architecture used to develop the Majorana 1 processor offers a clear path to fit 1 million qubits on a single chip that can fit in the palm of one's hand, Microsoft said. This is a needed threshold for quantum computers to deliver transformative, real-world solutions, such as breaking down microplastics into harmless byproducts or inventing self-healing materials for construction, manufacturing, or healthcare. Now, listen to this last phrase. All the world's current computers operating together can't do what a 1 million qubit quantum computer will be able to do. So this is actually insane. Like, I know I say that all the time, but for real, this is truly insane. We are on the cusp of developing actual working quantum computers, and to do this, we literally had to invent a new material atom by atom just to be able to observe these quantum particles, these Majoranas. This isn't just a breakthrough in computing, it's a fundamental shift in material science and physics. As they mentioned before, it's like we've just invented the semiconductor, and now we're about to use it to build the first ever computer, but on a scale much bigger than we can even comprehend. And here's the craziest part. We already managed to create insanely powerful AI systems with classical computers. Now, imagine what's possible when we combine AI with quantum computers that are more powerful than all of the computers we have now combined. I legitimately can't even imagine what our world will look like in the next 50 years, let alone the next decade. Now, switching gears a bit, Microsoft also recently introduced Muse, a generative AI model designed for gameplay ideation. They state here, today the journal Nature is publishing our latest research, which introduces the first world and human action model, WAM. The WAM, which we've named Muse, is a generative AI model of a video game that can generate game visuals, controller actions, or both. So getting right into some of the examples here, this is essentially an AI model that predicts the next frame in the game based on the user's controller movements. They start off by feeding the model 1 second or 10 frames of real human gameplay, and then feed it only the controller actions of the user and have it generate everything else in real time. Now, as they show here, the model gets significantly better at doing this as they scale up compute. It starts to literally learn the game mechanics, such as this character's flying ability, and at high compute can generate continuous gameplay for up to several minutes long. So right now, Microsoft sees this as more of a brainstorming tool for game developers. They're open sourcing the model weights and sample data, allowing everyone to experiment and learn from it. But think about where this could go. Right now, it can generate several minutes of continuous gameplay, though it's far from smooth. But what happens in 5 or 10 years when AI can generate hours of cohesive, real-time gameplay at 60 FPS, indistinguishable from traditionally developed games? It could completely redefine game development, game design, and even how we experience interactive entertainment in general. Also, we have Elon Musk announcing that xAI plans to start their own AI game studio. So overall, a massive week for Microsoft. I'm excited to see how the research progresses on this front. And of course, we'll be keeping an eye on xAI for any new information regarding their game studio. Speaking of xAI, as you know, they recently released Grok 3, and we now have an early demo of its coming voice mode. Take a look.
Hey Grok, what's up?
Can you hear me? I'm so excited to finally meet you. I can't wait to chat and learn more about each other. I'll talk to you soon.
So, not the longest demo ever, but according to Musk, we should be getting it sometime this week. Now, before we get into the last story of the day, which is Google's introduction of their new AI co-scientist, there was this recent clip of Yann Lecun, a prominent figure in the AI space known for his rather conservative or even skeptical viewpoints, discussing the future of AR glasses combined with AI agents. I personally think this is a massively underrated technology. Only a handful of companies are seriously working on AR glasses, notably Meta, and with the rise of AI agents, there is a ton of untapped potential here. Check this out.
When are we going to get human-level AI? Do we need human-level AI? Yes, because we're going to walk around with those smart glasses, and we're going to need to have sort of human-level AI systems that we can talk to them. Those glasses don't have a display, but within the next year or so, we're going to have glasses with displays and with EMG interfaces, so we can like point and click with our fingers, type with our hands in our pocket, things like that. And pretty soon that's going to be the new computing platform, and it's enabled by AI. And then in a few years we'll have like full augmented reality glasses. But right now that's too expensive. So in the future, all of us will be walking around with basically a virtual staff of super smart virtual people helping us in our daily lives. It's like every one of us would be kind of a boss of a staff of people, right? All of us would be sort of a manager, if you want.
So let me know what you guys think about this. Are you bullish on AR glasses? Do you see them becoming the primary user interface, eventually replacing iPhones, computers, and everything else? Drop your thoughts in the comments. Finally, this brings us to Google's AI co-scientist. They state, we introduce AI co-scientist, a multi-agent AI system built with Gemini 2.0 as a virtual scientific collaborator to help scientists generate novel hypotheses and research proposals, and to accelerate the clock speed of scientific and biomedical discoveries. So we won't go into too much detail about how this AI co-scientist actually works, but here's a graphic that gives us kind of the surface level of what's going on. So they use test time compute to generate quality and novel research ideas. This essentially means they use a reasoning model. Now, once this reasoning model comes up with a good novel idea, the human scientist will give the AI co-scientist a specific research goal. This kicks off a very complex process of multiple AI agents working together, all responsible for separate things, such as conducting research on the web, comparing and contrasting ideas, ranking ideas, verifying ideas, and more. The end result of this is the generation of novel research hypotheses or proposals based on the research goal for the human scientist to choose from. Now, before we go any further, I just had to bring up this graph from ex-OpenAI researcher Leopold Aschenbrenner's famous paper titled Situational Awareness. I know I reference this a lot, but for good reason. As you can see from this graph, the moment we automate AI research, meaning AI itself is conducting AI research, is when we can expect to see an intelligence explosion. This makes sense because once AI systems start improving themselves, those improved systems can in turn create even better AI, leading to a positive feedback loop, also known as recursive self-improvement. Right now, with Google's AI co-scientist, we're seeing the fusion of reasoning models with AI agents capable of conducting autonomous research on the web. This combination has already accelerated scientific discovery at an impressive rate, as we're about to see. But what if this same approach were applied to AI research itself? While this might not be entirely possible just yet, otherwise it would have already been done, this research suggests we may be getting close. As they state here, the AI co-scientist leverages test-time compute scaling to iteratively reason, evolve, and improve outputs. Key reasoning steps include self-play based scientific debate for novel hypothesis generation, ranking tournaments for hypothesis comparison, and an evolution process for quality improvement. The system's agentic nature facilitates recursive self-critique, including tool use for feedback to refine hypotheses and proposals. So this AI co-scientist is already basically an example of self-improving AI. It quite literally gets better by debating itself and by constantly ranking its generated ideas to find the best one. Here is a real-world example of Google's AI co-scientist speeding up scientific discovery immensely. As you can see from the title of this article, AI cracks superbug problem in 2 days that took scientists years. The article states, a complex problem that took microbiologists a decade to get to the bottom of has been solved in just 2 days by a new artificial intelligence tool. Professor Jose R. Penades and his team at Imperial College London had spent years working out and proving why some superbugs are immune to antibiotics. He gave co-scientist, a tool made by Google, a short prompt asking it about the core problem he had been investigating, and it reached the same conclusion in 48 hours. He told the BBC of his shock when he found out what it had done, given his research was not published, so could not have been found by the AI system in the public domain. So this is wild. I mean, it's already solving problems that took human scientists years to solve, and it's not just finding this information on the internet. As the professor said, this research could not be found in the public domain. He even mentions that he was so spooked, he wrote an email to Google asking if they had access to his personal computer. He further stated that it's not just that the top hypothesis they provided was the right one, it's that they provide another 4, and all of them made sense. And for one of them, we never even thought about it, and we're now working on that. So again, this is just wild. We officially have AI co-scientists now, and it's only a matter of time before we have AI scientists. By the way, for those who are interested in what this research is actually about, they give a bit of an explanation here. It states, the researchers have been trying to find out how some superbugs, dangerous germs that are resistant to antibiotics, get created. Their hypothesis is that these superbugs can form a tail from different viruses, which allows them to spread between species. Professor Penades likened it to the superbugs having keys, which enabled them to move from home to home, or host species to host species. Critically, this hypothesis was unique to the research team and had not been published anywhere else. Nobody in the team had shared their findings. So Mr. Penades was happy to use this to test Google's new AI tool. Just 2 days later, the AI returned a few hypotheses, and its first thought, the top answer provided, suggested superbugs may take tails in exactly the way his research described. So I'm not too familiar with the research behind how superbugs work, but if any of you watching this are, feel free to leave your thoughts down below. Anyways, that is all the AI news for today. What an absolutely incredible week in AI. I hope you guys enjoyed the video and hopefully learned a thing or two. And as always, if you want to stay up to date on future AI news just like this, make sure to hit that subscribe button.